Now let's talk about the other ways of viewing or of imagining aspects of this graph, because this is a graph of our function f of xy equal 4x squared plus 9y squared. Give me an x and a y in a good graph. I'll find the xy point down here in the xy plane, and then I'll see how high I got to go before I straight up before I hit the graph, and that's my value of f of xy. And that, of course, again, is the z coordinate of the corresponding point. Another thing we can look at is slices of this surface. Okay, so I'm going to slice this surface with the plane x equals 1/2. Now x equals 1/2, let's say about here. So this line is in the xy plane at x equals 1/2. Now my plane x equals 1/2 will go up and down vertically from this line. So you just take this line, move it upward, take it, move it downward. You get the plane. That plane intersects this elliptic paraboloid, and it might be along this curve. Okay, this curve might be a parabola. You suspect it might be, but you have to prove it. I just plug in x equals 1/2 here and see if you end up with a parabola. You will, so you can prove it. But we have the x equals 1/2 plane, and within that plane, the intersection with the curve, the intersection with our graph, is a nice curve in that plane. Okay, so if we want the rate at which the x value or the z value changes with respect to x within this plane, we can just go to this curve and ask questions. Okay, so we'll see more of this. I'm giving you a preview of a good part of the entire chapter 4, and it's a fairly long chapter. So how would we write down the intersection of this graph with the plane x equals 1/2? Well, the graph is the surface z equal, 4x squared plus 9y squared minus z equals 0. Or z equals 4x squared plus 9y squared. Z equals f of xy. So using this form, if x equals 1/2, then we plug in 1/2 for x. X squared is going to be 1/4. 4x squared is going to be 1. Our z is going to equal 1 plus 9y squared. Now in the yz plane, what is that? Well, z equals y squared is just our standard z equals y squared parabola. Okay, goes through the point 0, 0, 1, 1, 1, negative 1, 1. Has all the characteristics of a parabola. If we have 9y squared, then we stretch that parabola by factor 9, gets skinnier, but it's still a parabola. And if we add 1, then z gets 1 larger, so that the vertex, which would, before we add the 1, be at the origin, goes 1 unit up in the z direction. And we have the curve that looks like this, 1 unit higher than the xy plane, and a parabola. Okay, I'm going to wave my hands a little bit in the next video just to give you more of an idea of slicing this thing.